Good evening. I had an experience a few months ago where I received an email, and the content of the email was someone was asking me whether in the math department at UCSB we teach the new math. And that got me really curious, because have you ever heard that term? Like, they're teaching the kids the new math now. Have you heard that? And that got me really curious because I've never heard a mathematician say we're teaching the new math. And I've also never heard an educator say we're teaching the new math. It's kind of something that I do hear out there, and it's really not a thing. I just want to throw it out there. There's no new math, but there is something new. Obviously, Common Core is our set of standards now. People understand that. There is something new, but it's not math. And I guess I just want to leave you with that point. There's my slide. I saw a movie over the summer. You might have seen it too, and see if you can guess the movie that I'm talking about. There's a father and a son sitting at the table together, and the son says, "That's not the way you're supposed to do it, Dad. They want us to do it this way." And he holds up a book, and the book says, "New Math for Life." And the dad says, "I don't know that way. Why would they change math? Math is math." And the son says, "It's okay, Dad." And the father, he kind of slams the table and he says, "Math is math." Do you know what movie I'm talking about? Have you seen it? You know what it is, right? What is it? Yeah, it's Incredibles 2. And it's it's Mr. Incredible and his son there are having this conversation. So I understand, and I laughed. I laughed at that, right? I understand where it's coming from. Personally, I think it's a little bit of a misconception about what's going on right now. Math is not changing. But I understand it, because your son or your daughter or your grandson or your granddaughter comes home and they share their math homework with you, and you look at it and you go, "I don't really remember doing it that way." And yet, that's what we're doing. But it's not the math that's changed. It's something else, and I want to talk about it. I'm going to invite you to do a quick addition for me. 346 plus 198. In your head? Just in your head. Okay. Maybe, in your head, you might have done that. I don't know if you did or not, but you can sort of decide for yourself whether you did that. Or, maybe you did something like that. You took 346 and you added 200, and you got 546, and then you took 546 and you subtracted 2, and you got the answer, 544. I bet it's, even though you did that since you were in second grade, I bet right now you probably did something like that instead. And you might bring home some student, when your son or daughter or whoever comes home and they share their work with you, they might have a picture on their page that looks like that. And for some of us, I never learned that when I was a kid. And for some of us trying to help our kids with homework, that looks very foreign and a little weird, right? But what I want you to know is teachers are really, really trying to connect with students in a different way, which is not so much on procedural knowledge. This representation over here is procedural knowledge. Kids can generally do that, but they don't really understand why it works like that. Why do I carry the 1? If you ask them, that oftentimes it's because that's what my teacher told me to do. But a student who can work out this problem in that way is demonstrating more than just procedural knowledge. They're demonstrating what we call conceptual knowledge, which is a broader understanding of the way mathematics works. So if I say, I need to add 198, instead of just adding 198, I can add 200 and then subtract 2. That's an understanding of mathematical structure, and that's what we're really trying to get at. So that's not new, by the way, right? That's not new, but teachers are making an attempt to try to put students in a place where they can have better conceptual knowledge. And those kinds of representations, this is called an open number line, those kind of representations are helping children to have a broader sense of that part of mathematics. Here's another example, multiplication, 32 times 53. And this is probably what you're familiar with, I would imagine. this kind of algorithm, right? We call this an algorithm or a procedure, and students can do this by and large. But why do you move the 160 over a notch? Does anybody know why you move the 160 over a notch? Most people don't really know, other than to say, my teacher told me that's what I'm supposed to do when I do this multiplication problem. And then here's another example of something that you might see on your children's or your grandchildren's homework when you're trying to help them, and you probably don't recognize it either. This is called an area model. And the basic idea is that 30 plus 2 is on the top, and 50 plus 3 is on the side, and I'm basically going to multiply those two by thinking about it as a rectangle. And when I multiply the length and width of that rectangle, I'll be getting the area of that rectangle. That's why it's called an area model. But I can split it up into 30 and 50 and 2 and 3, and I can see how the area of the 30 by 50 piece is 1,500. You got 100 over there, 90 and 6, and then you add those up and get the same number. Again, the concept is a better feel for what's going on when we talk about multiplying numbers together. And I just have one more for you, and that is this. X plus 2 times x plus 3. This is more like a high school or junior high problem, but does anybody remember the technique? We got FOIL. Does FOIL sound familiar? Okay, FOIL goes like this. FOIL. Multiply the first 2, multiply the outside 2, multiply the inside 2, and multiply that last 2. Add them all together and get an answer. X squared plus 5x plus 6. Can anybody in here tell me why FOIL works the way it does?
My teacher told me to do that.
Your teacher told you to do it that way, exactly. That's what people remember. My teacher just told me to do it that way. They don't really have a conceptual understanding of what it means. These are called binomials. They don't really have a conceptual understanding of what it means to multiply those binomials together. So, the area model is a representation that helps children, junior high and high school age children, understand why is it that you need to multiply the first, the outside, the inside, the last. Because when you have x plus 2, that you could think of that as being like the length, and x plus 3 could be the width, and when you multiply those together, you get all those pieces. So when your grade school teacher is doing this, and you're going, I don't really understand, why do I need to do it like that? Because I already have an algorithm. I already have a way of getting that number. Why are they making me do this? And this is why, because we want them to have a better conceptual understanding about what's happening behind the scenes so that when they do get here, this will make sense for them. So, bottom line is, there's no new math, but there's new ways of thinking about doing math and trying to get mathematical conceptual understanding. So that's it. Thank you.